Hello again, it is I, Derek from Tomcat Gas Training, and welcome to this video where I need you gas engineers and trainee gas engineers to help me out. Anyway, before we get into this video, please could you take some time to subscribe because it helps my channel. And don't forget to hit that notification bell because you want YouTube to tell you when we're uploading videos. If you're new to the channel, it's Mondays and Wednesdays. Also, don't forget to give us that thumbs up. So, that's enough waffling and fluffing, and I'm sure you're interested to find out what this is all about, so let's get on with it. Now then, what is this video all about, and why do I need your help? Well, I've had a message off a guy on one of my YouTube videos, and it's the YouTube video where I talk about gas cookers and testing gas cooker controls. And it got me thinking. It also got me in a rage, but it got me thinking, am I actually doing these tests right, or am I doing them wrong? Because this guy reckons, or kind of puts across, that he's a trainer. And the guy is called Paul Carter. So if you know a trainer called Paul Carter, then he's the guy who sent me this message. This could just be a troll trying to get a reaction from me, but there's nothing better than this kind of reaction. But I just want to read out what he actually said to me, or what he wrote, and this video is basically going to go through what he said and how I do the tests. And at the end of it, guys, I want you to put down in the comment section below whether you think Mr. Carter, as we're going to call him for the rest of this video, is correct and I'm completely wrong. So, let me read out what he says. So he says, okay, up to the point where you blew out the flame to test the FSD and the liquid expansion thermostat, unbelievable, you created a gas escape, potentially filling the oven with gas, and it would have been very much safer to isolate the gas at the AIV. I guess he means the appliance inlet valve, which is a requirement of BS 6891-2015 and regulation 26.6. So that's the first part he wrote. Now then, BS 6891-2015, I have a copy here. Now I've read this on numerous occasions, and I can't think off the top of my head anywhere in here where it says how to test safety devices on a cooker. So, why would the specifications for the installation and maintenance of low pressure gas installation pipework of up to 35mm or R inch and a quarter on premises have anything to do with testing cooker controls? I could be wrong. So you guys out there who read these religiously, because I know there's some who do, could you tell me if Mr. Carter's right about that? Because I couldn't be bothered going all the way through it because I don't think it's in there, because I know what the British standards are like. Did he actually mean the British standard for cookers, which is 6172, which is the specification, installation, serving and maintenance of domestic cooking appliance, second and third family gases? Did he mean that one? But in this one it says, when coming to check the safety devices, it says refer to the manufacturer's instructions. So if that one says it, I'm sure that one does as well. Shall we read on? So the second part he says, and you are teaching new candidates. Are you gas safe registered? Yeah, I've been gas safe registered and Corgi registered for a very, very long time. Right back from the beginning. Anyway, I cannot believe a gas trainer, me, is teaching an unsafe method of testing cooker controls. I advise any learner who is studying for their ACS to ignore this. If you did this during your ACS assessment, you would be referred for unsafe working practice. It also concerns me that qualified engineers leaving thumbs up to this. I suggest you seek some further training from a competent trainer. So he's not just insulting me, he's insulting you guys as well, saying you don't know how to test them, and it's kind of coming across as if he's the only guy in the world who knows how to do this. So he mentions regulation 26.6. I've got the Gas Safety Installation and Use Regulations 1998, which was amended in 2018. And if I look at paragraph 26.6, it says, no person shall install a gas appliance without there being at the inlet to the means of shutting off the supply of gas to the appliance, unless the provisions of such means is not reasonably practicable. Where does that say how to test gas controls? Anyway, to add insult to injury, Mr. Carter actually put another message on. Not actually another comment, another one, so everybody could see it again. He put, I strongly suggest you seek retraining from a competent trainer as you are working unsafe. If you come to me for assessment, so that's kind of saying he's an assessor as well as a trainer, you will be referred. I was shouting that, big letters. You clearly do not understand fully how gas controls operate and how to test these controls safely. Your explanation regarding the operation of a thermoelectric valve is wrong and you are misleading learners. Okay, so I wonder what was wrong about it. I'll probably have to go back and watch the video, won't I? No, I won't. So, what I'm going to do in this video, like I said, is I'm going to go through these tests again. I'm going to demonstrate them the way I train them. And the way I train them is so the trainees understand how they work and how to test them if they think they are passing and failing. What he is talking about, good old Mr. Carter, is what the book says. And that means he's training out of a book rather than his own knowledge. And that's always a bit frightening, isn't it? That a trainer can only train from a book, he can't train from his mind. Anyway, he says he's an assessor. Whether he is or not, I don't know. But he says he's an assessor and he would fail somebody if he carries out these tests on an assessment. Well, I'm also an assessor and I'm also an internal verifier as well. So we have management meetings all the time with our trainers and assessors. And we discuss controls and stuff like that, because we've just had a technical bulletin about the cooker lids and a few training centres they've shattered. But the way we train it here, they've got to be pretty bad trainees to actually shatter a glass on a cooker lid the way we train it. But it's not the way the book tells you. So what does that tell you? Anyway, I am waffling, so I need to stop waffling and I need to get on with it, and I need to, hopefully, at the end of this video, I'm either going to look a complete balloon and lose that tiny little bit of credibility I've ever got in my training life. And I started off, as I say, as a gas trainer in 1999, and I've owned my own training centre since 2001. So yeah, so let's get on with it and see what you guys think. Please, when you put the comments down below, I want you to be respectful and I want you to be truthful. Don't slag me off. You know, don't start talking about my teeth and I've got no hair and all that kind of stuff, because that's not going to be helpful. I just want to see what you guys think about this comment, what this guy's put in, because nobody ever comments on poor comments. Anyway, let's get on with it. So, this is the cooker in question, which we were talking about. So, first thing I'm going to do is light it. So in the video I say you've got to press the button in to override a safety device. Well, you're overriding a safety device because these have got stops, so you can't turn them on accidentally. You have to press them in to override the stop, otherwise, oops, knob came off. Otherwise, they would just be able to turn on. So you're overriding a safety device. So the safety device. And when you do a thermoelectric device, you're overriding the thermoelectric device. So on this one, you're overriding the anti-gas tap turner on her, if there is such a thing. Anyway, press the button in, let's turn it on to maximum and light it. So now I can take my hand off straight away because we've lit the gas. So what this gas is doing now via the bypass rate is it's heating the file up for the main burner. Okay, so as long as I've got this knob turned on, gas is going to come out via the bypass rate, so remember that. So what's happened now is the liquid vapour in the file has vaporised, operating a set of bellows which has opened the main gas valve coming down to this liquid vapour device. So what I'm going to do is I'm going to close the oven door because I want it to get up to temperature, and I'm going to turn it to slow cook or simmer. So what this is going to do now is, like I explained in the original video, it's going to go down to back to the bypass rate because the mechanical thermostat within this cooker is going to turn off the gas supply going to this burner. That's basically the pilot light. So when it gets up to temperature, it keeps that going because it's the pilot light. But what you're going to hear is it's actually going to reduce the amount of gas coming through into the burner, and you're going to hear the burner's going to go down slowly. Now, there's no glass door in the front of this, as you can see, so you're not going to actually physically see it go down. But when we look at the other one, you will see that. So what we're going to do in this video is I've got another camera set up on the gas meter on this cooker. So when I blow out this bypass rate, what you're going to hear is gas start to come back up because the temperature of the oven is going to drop, so the mechanical thermostat is going to open the gas supply, but because the liquid vapour is going to cool down, it's going to knock off the gas coming to the main burner, but it's going to keep the gas in by the bypass rate. So these will never ever turn off. They will always pass through the bypass rate. So this guy's told me I'm dangerous blowing out this because of the amount of gas what's going to come out. So we're going to actually see how much gas is coming out of this burner when I blow it out. Remember, when you purge 0.01 meters cubed into the air with windows open and all room ventilated and all the rest of it. Now I've got the windows open and the rooms ventilated. I've even got the door open which leads to the corridor. So everywhere's vented. I am in full control of this. I'm not running away once I blow it out to go and get me breakfast at McDonald's. I'm staying in front of this cooker. I'm going to time how long it takes for it to knock off. If it fails to knock off within the time, I can just turn the gas off. I'm in full control. And then I don't light anything then until it's ventilated for a few minutes. So how's this dangerous? Anyway, let's first of all find out exactly how much gas, because we're up to temperature, is coming out of this liquid vapour once we blow out the gas. And I'm simulating in real life like it would do if it blows out by a gust of wind or something. So anyway, let's try it. So there you go. It's fully off now, but it wasn't. It was still going through the bypass rate, but it would have still registered on the other camera. So let's find out now exactly how much gas has been passed through that meter. So shall we look at the results, because they're on the board. So that was our first figure, 6.447. Okay, so the red boxes are simulating what you would see on a gas meter. And our second figure after we blew out the gas was 6.4484. Now you can see I used the little marks between the full figures in this. So this is your decimeters cubed, so this would have to go all the way around, so that would have to go all the way back to 7 again to make this figure move, okay, which would be 10 decimeters cubed. So when you purge 10 decimeters cubed or 0.01 meters cubed. So that would be 0.01 meters cubed. So that figure would have to go all the way around back to 7 again to make that move 1, which would be your purge volume. We have moved just 5 little marks. So that would be 0.5 decimeters cubed. So it's not even 1 decimeter cubed, it's half of a decimeters cubed. So you could say when you're purging, you're actually putting gas and air into the air. Yeah, I get that. Okay, so, but this is only a tiny little amount of pure gas, because it would be pure gas. We've also got our lower explosive limits of 5 to 15% gas in air. So we could have that happening, but all the windows are open, the doors are open, and this room's massive. Now you could say the cooker compartment could make the 5 to 15% gas in air, but tell me this, Mr. Carter, why does it still pass gas through the bypass rate once the main burner's been blown out? Wouldn't you think that would be dangerous? And won't the manufacturers of the burners think that's dangerous? Well, they obviously think there's not enough gas there to create an explosion or an explosion in a house, otherwise it couldn't happen, could it? Am I wrong? Please tell me if you think I'm wrong and I've created a dangerous situation. This valve, we also checked that the main burner knocked off within 25 seconds. So it was well under the 60 seconds which the manufacturers say it would knock out. I'm really struggling to find this is dangerous. I really am. So please guys, if you think I am dangerous and this process is dangerous, which I've been teaching for a very, very long time, and so far, touch wood, there's nothing's ever happened. But they do say miracles do happen. Anyway, just like I say guys, in the comments below if you think this is a dangerous amount of gas and would blow a house up, or an engineer testing it. Now, what I'm going to do now is I'm going to show you that the test this Mr. Carter is kind of referring to. So if he is a trainer, this is probably how he trains it. So, first thing is, what the book says is, turn it on to maximum, light it, and it should light in low rate, which you can quite clearly see this burner is lit in low rate. Then it says, wait for it to go up to full rate. So you can now see and hear that the burner has gone on to full rate. Now then, what it says to do is, turn it off and time with the stopwatch for 60 seconds. You ready? So, turn it off. And now time with the stopwatch for 60 seconds. So, I'll speed this bit up because you don't want to be sat here watching me looking at a stopwatch for 60 seconds. So, I'll speed it up. "58, 59, 60. So, that's our 60 seconds up, our minute. So now what they say is, turn it back on again, and if it lights in low rate, then it's fine. But we saw they did that. As soon as we turned it on, it lit in low rate. So doing it Mr. Carter's way, what haven't we checked? Well, first of all, we haven't checked, let's turn it off because it'll get too noisy. We didn't check how many seconds it actually took to knock off, did we? We just turned it off and then timed for 60 seconds and then see if it stayed in low rate. Also, we haven't tested to see whether the main burner is passing because we turned it off. We also didn't check the mechanical thermostat was working as well. So we would have to turn it all back on again to check that. So, which do you think is the safer one? Well, turning it off is the safer one, isn't it? But which is the one what gives you all the information you require as a gas engineer? Put it down in the comments below, guys, if you think Mr. Carter's test is the way we should all be testing liquid vapours, or the way I've shown you at the beginning. So I'll leave it up to you guys. Shall we move on to thermoelectric? Now, next one. Good old Mr. Carter says, I have no clue whatsoever on how a thermoelectric valve works. I've probably described this God knows how many times, and I've done quite a few videos on it. So anyway, this is a thermocouple which is connected to a thermoelectric device. This is an oven thermostat and main oven valve off a model just the same as this one. So this is where the main gas comes into the valve. You press the knob in, you'll see that in a minute, and it puts gas down there. But this can turn the gas off via the thermocouple. So the thermocouple goes into here, into that bit there, which has two dissimilar metals in there. When you put heat on it, Thomas Seebeck found out that it created a very low voltage in DC. So it's like, I've known them go about 8 to 30 millivolts DC. Anyway, so that's how that works. But what it does is, inside here, electron magnet with a coil in it. So that's where the thermocouple goes onto the end there. Like that. But it's not enough to suck the valve seat off. You press that, when you press your knob in, you override the thermoelectric device. So it can heat the thermocouple up. So it can then make the electric supply to be able to keep that open. Put in the comments down below, guys, if you think I'm wrong. But that's how it works. Anyway, so the test I did was find the main oven, which is this one. Press, oh, I need to put the power supply on first. Press the button in and turn it. Can you hear the gas coming out? So that's gas coming out there. Full rate. So if I click that, it's lit in full rate. I need to hold this on for a few seconds so it makes the thermocouple work and holds open that thermoelectric device. So there you go, it's open. So what I'm going to do is I'm just going to close the door, and you might be able to see it through here, but they might not. Because what I'm going to do is, again, I'm going to check out the mechanical thermostat. This is the mechanical thermostat. I'm going to check this is working. So I'm maximising my time, and also when I train this, guys understand it better when they see what this does. Anyway, so what I'm going to do is to speed up the process, because I've been waiting a long time for it to get up to whatever 9 is, whatever the manufacturer says the temperature is. We always turn it to slow cook or simmer. And what we're going to do now is we're going to wait till it gets up to temperature. And again, you should be able to see and hear the flame. Now, you probably can't see it yet, but we're going to listen for it to go down, and hopefully the glass will clear so you can see it. But you will be able to tell by the noise. So, what I'm going to do is, like I did in the other video, I'm going to blow it out. And then I'm going to start my stopwatch and see how many seconds it takes to knock off. Now, since 2000, everything's supposed to shut off within 60 seconds now. But before 2000, different appliances could have different knockout times. So you would always refer to the manufacturer's instructions. But if you know the appliance has definitely been built after 2000, like this one has, it's only a couple of years old, then it should knock off within 60 seconds. Now also what they say is, if they knock off before 10 seconds, there could be a fault with the thermocouple, or it's about to go out. It's about to break. So bear that in mind as well. So we're just waiting for this flame to go down. It's still quite high. And like I say, I'm going to blow it out, start my stopwatch as soon as I blow it out. I'm not going to touch this and see how long it takes to knock off. And again, you might hear the gas flow come back up again, because once I open the oven door, the mechanical thermostat will kick in and open the bellows of the gas valve more. Okay? So once I blow it out, then it's got within this 60 seconds to knock off. When you hear the click, that means the thermoelectric valve has closed. It's lost that electricity to hold it open, and then it's closed shut against the seat, and that stopped the gas going through. Now this doesn't have, when this shuts down, it's not got the bypass rate to keep it open. It should be completely off, and me pressing the ignition here should prove that. Okay, you can see it's gone down, so I'm going to blow it out now and start the stopwatch. Okay, that took 33 seconds. Now, if I press this ignition, we shouldn't get it lighting. Also, if I go off what our best mates told us, this should blow up in my face. Oh, it's not blown up in my face. There's not enough gas there to blow up in my face. We've proved that from the last one. I suppose I could do another video on how much gas it passes out, because this does pass quite a lot more than that one. But it's not blowing up. Okay, and also it's not tried to light the burner, so I can pretty much say that hasn't passed when it closed. Also, because I turned it down to simmer and waited till the burner had gone down before I blew it out, I was also minimising the amount of gas what was in the cooker anyway, because it was just on the low rate. Alright, you did hear it come up a little bit, like I said it was going to do. As it cools down, it puts the burner up a little bit, so it put a little bit more gas in. So that's why I was confident in showing you the ignition straight away, because I couldn't smell any gas coming out. Now, obviously, this is the most dangerous bit, because if it was full of gas, then you could get... So when you do test them, don't get your head in the front of it. Wait a few seconds to allow if there is any gas there, to come out. You're fully understanding the way of gas works there, aren't you? Am I? Or am I not? Again guys, get in those comments down below and tell me if I don't understand how this works and I'm making a fool of myself. Now, what good old Mr. Carter's saying is, this is how he probably trains it. So what he will do, we'll leave the door open for now. We'll turn that off. We will relight the oven again. Didn't leave it open long enough. Okay, so what he says is to do is leave it on full, leave it for a few minutes to warm up, then turn off the gas control and start your stopwatch and listen for the click. So, now let's listen for the click. A little bit longer this time. It took 35 seconds for it to do the click. Now, what do you see is the problem with Mr. Carter's way? I don't know whether the thermoelectric device is passing, do I? Because when I turn this off, I turn all the gas off. I'm not testing the safety device. I'm actually testing the control knobs turning off. Even though the thermoelectric device is clicking out, I'm testing it clicks. I'm timing how long it clicks, but I'm not testing whether it's passing or not. So, who's right and who's wrong? Or are we both right? Or who's testing the most? Because I'm testing the mechanical thermostat's working, as well as my thermoelectric, and my thermoelectric isn't passing. Where good old Mr. Carter, the way he teaches it, is just testing the thermoelectric kicks out within 60 seconds, but doesn't show whether it's passing or not. So, am I just being an absolute wally here, guys? Am I just reacting to a troll? Or is Mr. Carter completely right? I'm unsafe. I'm relying on you guys to put the comments down below and tell me whether you think I am what Mr. Carter says, a poor trainer, a dangerous to society, and I need to be retrained by him, probably. So, again, guys, let me know in the comments below what you think. And that is the end of this video. Now, these are the videos I don't want to be making. I've made 2 now on comments. So really, I shouldn't be bothered with comments, but because this one was, I don't know, about training, it really yanked my chain. So, am I right? Am I wrong? I need your comments to tell me whether I'm right or wrong, or whether I actually give up doing these videos on YouTube. Because all these videos are ever made for is to help guys in their training. I make mistakes in these videos. Everybody makes mistakes in life. But hopefully I'm not dangerous. Because I would certainly be mortified if guys out there thought what I was training and getting over to them was dangerous, where I'm a big advocate of safety in our industry. And this is why I do these videos, to hopefully make our industry a tiny little bit better than it is, and give out the new trainees some of my experience of being in the gas industry for all these years I have been doing. So, if you have liked this video, give it a thumbs up. Or don't forget to leave that constructive comment down below. If you're not subscribed to my channel, then please subscribe because it helps. And don't forget to hit that notification bell, because hopefully I'm going to be releasing videos in the future. All I've got left to say is thanks for watching, guys. Thanks for listening, and be safe out there.